solid plus water liquid will give 2 sodium hydroxide molecule aqueous. 2 molecules of potassium triosonitrate will give 2 molecules of potassium triosonitrate and oxygen. 2 molecules of sodium tetraosonitrate will give 2 molecules of sodium triosonitrate plus oxygen. Group 2. Calcium and magnesium belong to group 2. They are divalent elements since each of their atoms have 2 valency electrons. They are electron donors for electrovalent compounds and are reducing in nature. Calcium will donate 2 electrons to become 2 positively charged. Calcium reacts vigorously with cold water. This is fastened if the water is heated. Magnesium reacts with steam only. They both liberate hydrogen for water, but while calcium forms a hydroxide, magnesium forms an oxide. Calcium oxide dissolves spirally in water, form calcium hydroxide solution, which is very weak alkali, while magnesium oxide is practically insoluble in water. Calcium solid plus 2 molecules of water liquid to give calcium hydroxide aqueous plus hydrogen gas. Magnesium solid plus 1 molecule of water gas to give steam to give magnesium oxide solid plus hydrogen gas. 1 molecule of calcium oxide plus 1 molecule of water liquid to give 1 molecule of calcium oxide, which is hydroxide, which is aqueous. The triosonitrate 5 salt decompose readily on heating to give the oxide. Oxygen and brown gas, nitrogen 4 oxide. The triosocarbonate are insoluble in water. They decompose on heating to give the oxide and carbon 4 oxide. Two molecules of calcium triosonitrate will give, after heating solid, will give calcium oxide, 2 molecules of calcium solid oxide plus water plus carbon nitrogen 4 oxide gas. 2 molecules of magnesium triosonitrate 5 solid will give 2 molecules of magnesium oxide and the oxygen plus 4 moles of nitrogen 4 oxide. Calcium triosocarbonate solid will give calcium oxide plus carbon 4 oxide gas. Magnesium triosocarbonate solid will give magnesium oxide plus carbon 4 oxide. Group 3. The only familiar element in group 3 is aluminium. It is trivalent since each of its atoms has 3 valency electrons. Being a potential donor of 3 electrons, it is reducing in nature and forms electrovalent compounds. Aluminium will discharge 3 electrons to become 3 positively charged electrons. Aluminium reacts with steam above 600 degrees centigrade to liberate hydrogen. Aluminium oxide is insoluble in water. Aluminium hydroxide is prepared by precipitation. Both the oxide and hydrogen are amphoteric in nature, that is, they have both acidic and basic properties. They can form normal and complex salts with acid and alkaline respectively. Aluminium oxide plus tetraoxosulfate 6, 3 molecules of tetraoxosulfate 6 aqueous to give aluminium tetraoxosulfate 6 acid plus 3 molecules of water liquid. Aluminium oxide solid plus 1 molecule of sodium hydroxide aqueous plus water we give 2 molecules of sodium aluminium hydroxide. 2 molecules of aluminum hydroxide we give plus 3 molecules of tetraoxosulfate 6 aqueous to give aluminium tetraoxosulfate 6 aqueous plus 2 molecules of water. 1 molecule of aluminum hydroxide plus 1 molecule of sodium hydroxide aqueous to give sodium aluminum hydroxide aqueous. Aluminum triazoonitrate 5 decompose to give oxide, oxygen and nitrogen 4 oxide. Group 4. Group 4 elements include carbon, silicon, germanium, tin and lead. They are trivalent, that is, each of their atoms has 4 valency electrons. They tend to form covalent compounds. The most important group trend is change in the property of the elements from non-metallic to metallic on going down the group. There is also corresponding decrease in electronegativity, that is the tendency to accept electrons. The compound of the group 4 element exhibits 2 oxidation states of positive 2 and positive 4. The stability of positive 2 state compound increases and that of the positive 4 state compound decreases on going down the group. Carbon and silicon form more stable positive 4 state compounds, while tin and lead forms more stable positive 2 state compound. This is illustrated by various oxides of the group 4 element. Carbon and silicon forms covalent compound with hydrogen. The hydrides of carbon are very numerous and are known as hydrocarbons. Example are methane CH4, ethane C2H6, ethane C2H2, benzene C6H6. Example of silicon hydrides are monosilicate, monosilane SiH4, disilane Si2H6 and disilane Si3H8. Tin form a tin 4 hydride, which is less stable than those of carbon and silicon. Carbon does not react